Hello everyone and welcome to our channel Mootechie. It's wonderful to have you here as we dive into the fascinating world of food science. Today we're exploring a fundamental topic, meat processing technology. So let's get started. Following this we'll see our learning objectives. By the end of this lecture, you, the student, should be able to understand the nutritional composition of meat and the factors affecting that composition. And secondly, explain the steps for the conversion of muscle to meat. These are our two key goals for today. Coming up, we'll discuss the introduction. Meat and animal products form a crucial part of our global diet. In fact, they make up about 25% of the world's food supply. Let's break that down a little more. Meat itself accounts for about 4.5%. Fish is around 3%. Eggs are about 1%. Milk and milk products are a significant 16%. And other animal products make up the remaining 0.5%. Now let's understand this more clearly. What exactly is meat? Well, meat is animal flesh that is eaten as food. It consists primarily of muscular tissue, along with varying amounts of fatty tissue, connective tissue, and even some bone tissue. And what do we mean by meat processing? Meat processing is the set of methods and techniques used to bring substantial chemical and physical change in the natural state of meat. It's how we transform raw meat into the various products we see on shelves. So where does our meat come from? The common sources of meat include buffalo, cow, goat, sheep, lamb, pig, and poultry, among others. Let us now look at the general composition of raw meat. This is really interesting. On average, per 100 grams, raw meat contains about 74 grams of water. Yes, meat is mostly water. It has about 20 grams of protein, 5 grams of lipid or fat, and less than 1 gram of carbohydrate, with minerals and vitamins present in milligram amounts. Moving forward, we'll see the technology behind the conversion of muscle into meat. This is the transition of a live animal to a food commodity. It's a multi-step process, so let's walk through it. The first step is transporting the animals to a meat factory. This can be done by vehicle, train, or ship. This step involves VI, or veterinary inspection certification, noting the animal's sex, mass, and status. Proper transportation is vital to reduce loss in weight, injury, and sickness. We have to think about providing water, feed, and ventilation during this time, and the duration of transportation is a key factor. This leads us to a very important point: stress. Stress, in its many forms, is a serious concern. For example, deprivation of water or food, rough handling, exhaustion due to transporting over long distances, or mixing animals reared separately, which can result in fighting. This is unacceptable from an animal welfare viewpoint, and should also be avoided because of its deleterious effects on meat quality. And the most serious consequence of stress is, tragically, death. Next, we explore pre-slaughter handling. Animals are typically held for 2 to 3 days with all necessary conditions provided. We must avoid overcrowding. And about 2 to 3 hours before slaughter, we stop feeding them. Then comes stunning and slaughtering. Stunning is a means of immobilizing the animal so that they become unconscious and less aggressive. This is a critical step for both welfare and quality. There are 3 main methods of stunning. The first is electrical stunning. Here, an electric current of high frequency, but, in the case of manually operated equipment, of relatively low voltage, around 60 to 80 volts, is passed through the brain of an animal for a few seconds to produce unconsciousness. If applied correctly, a deep state of unconsciousness is invariably achieved. The second method is mechanical stunning. And the third is using CO2, or carbon dioxide gas. It's important to know that all processes done after stunning can be regarded as part of the dressing process. Following this, the next step is bleeding. Here, the skin around the neck is pierced, and a special sticking knife is used to draw the blood. The time for bleeding is typically 6 to 8 minutes. At this point, the animal is killed, a result from the lack of blood supply to the brain. Now let's talk about skinning. This process can account for around 30 to 40% of the whole work involved. It starts from the head, again under veterinary inspection. Several factors affect the removal of the skin, such as the type and sex of the animal, the specific parts of the skin and its structure, and the angle of the skin location. Coming up next is opening the abdominal cavity, a process known as evisceration. In this step, the internal organs are pulled out or taken out. This includes the heart, the liver, and the intestine. After that, we have splitting the carcass, commonly using an electrical saw. This is commonly done for cattle and pigs, but typically not for smaller animals like sheep and goats. And finally, the carcass goes into refrigeration storage at temperatures between 1 to 3.5 degrees Celsius. So what does all this processing lead to? Let's look at the variety of meat products we get. We have heat-treated processed meat. Examples include cooked ham, cooked pork shoulders, and canned chicken meat. Then we have cured non-heat-treated processed meat like side bacon, marinated beef, corned beef, and miso-pickled meat. And we also have cured and dried non-heat-treated processed meat such as dehydrated meat, dried salt pork, stuffed loin, pastomas, and dried sausages. Quite a variety. And we can't forget about the byproducts of meat processing. This is a fantastic example of using the whole animal. Byproducts include trimmings, bones, blood, and skin. Their applications are incredibly diverse. They can be used as fertilizers, like hoofs and horns, and bones or feet or shank. They can be used for biodiesel generation. They're vital in pharmaceutics, using glands and organs and blood. They're used in animal feed, again often using blood. And they're crucial for the textile and leather industries, using hair and wool and hides and skins. And that brings us to the end of our lecture on meat processing technology. Thank you. See you in the next class.